things that's neat about the whole sensing business is that it's not one thing, it's lots of things that have to happen to make this work. This is a part from a helicopter. This is called a pitch link or a control rod, and the purpose of this component is as the helicopter is flying, it's spinning round and round and round, and its job is to change the angle of attack of the rotor up here. The Navy asked us if we could monitor the loads on the pitch link wirelessly because they're spinning round and round. You can't attach wires to the darn thing. The other problem that the Navy asked us to overcome was to make it so that we don't have to power the device with batteries. How do we do this? The science of it, how does it work? Well, there's a board, we call it the pitch link board. It lives underneath all this protective covering. And attached to the pitch link down here are strain gauges, and those strain gauges are set up to measure the tension and compressive loads that this thing sees. This piece here is a piezo electric material, and piezo means stress in Greek. When the link sees cyclic strains, that generates power. In here are lots of little fibers running along the length of this, and those, when we apply tension to this, those fibers have a polarization, and that polarization creates voltage when it's stressed. But as long as you keep this stuff moving, it's going to keep generating electricity. That allows the pitch link board to acquire the loads data, record it, and transmit it perpetually without any need for battery maintenance. What's important about the pitch link and why the Navy wants us to measure its loads is when helicopters are undergoing aggressive maneuvers, turns and pulling up very rapidly, these loads, the loads on this link go up 8 times that of straight and level flight. So if you're measuring the loads on this component, you're not only learning about it, but you're learning about the loads on all the rotating parts of the helicopter. Currently, most of those components are replaced solely on the basis of flight hours. With a tracking system, you would be able to replace those components based on the fact that they've actually accumulated damage and need to be replaced.